I'm Dr. Jacob Gran, and this is the fourth video in the series on Schenkerian analysis. In the previous video, we learned about horizontalization and the ways in which composers can use arpeggiation, unfolding, register transfer, and other techniques to open up new melodic space. Those horizontalized intervals often form the boundary points of goal-directed melodic motions. In this video, we will learn about diminution and the various ways that composers can fill in those newly created melodic spaces. The word diminution has various meanings for musicians. Often when we are talking about motivic development, we will use the term diminution to mean a speeding up, the opposite of augmentation. For instance, a fugue subject in half notes might later be presented in quarter notes. Schenkerians have taken to using the term in a similar way, although as I've stated previously, rhythmic values have different meaning in analytic notation compared to standard notation. Moving into faster note values in this context simply means composing out a pre-existing structure, moving from a middle ground towards a foreground. It is in that sense that all of the transformations discussed in this video are diminutions. In Gradus ad Parnassum, Fuchs uses a third meaning of the term diminution. In Fuchs's day, a diminution was a kind of ornament that referred to the filling in of a horizontalized interval with stepwise motion. Fuchs introduces the dissonant passing tone in second species as an example of this kind of diminution. Fuchs would ask us to think of the passing tone A in this example, which forms a dissonant ninth against the G in the cantus firmus, as a filling in of the interval of a third between B and G of the downbeats. If the A were removed, the downbeat consonances would form good first species relationships with the notes of the cantus firmus. The conceptual relationships between these notes is best illustrated through analytic notation. The slur in this example shows the relationship of a consonant skip of a third between B and G in the counterpoint voice. Those two tones are given stems because they exist conceptually prior to the unstemmed A on the upbeat. The A is contained underneath the slur because it is dependent on that melodic connection. Diminutions can also happen between intervals larger than a third. This is a tricky example of third species counterpoint. Notice that because the fifth formed on beat 2 is actually a dissonant diminished fifth, we have consecutive dissonances on beats 2 and 3, which normally would not be allowed according to Fuchs. Contrapuntal theorists after Fuchs have made an exception for this configuration, however. The notes F and E in this passage can be thought of as being created by a diminution that fills in the interval of a perfect fourth between the G of beat 1 and the D of beat 4. When we convert this measure of counterpoint into analytic notation, we can see that the two stemmed notes, G and D, which are connected by a consonant skip, form a good second species relationship against the cantus firmus. Although Fuchs did not use analytic notation in Gradus, he explained using his prose how diminutions can generate dissonance in the later species out of pre-existing consonant relationships in earlier species. We've seen diminutions for an interval of a third and here a fourth, but diminutions can also be formed to fill in consonant skips of a fifth, a sixth, or an octave, or they can be used to connect the tones of an arpeggiation. One of the most important pieces of vocabulary in Schenkerian analysis is the linear progression. Oftentimes, analysts will use the term linear progression to mean exactly the same thing that Fuchs calls a diminution, so don't be surprised if these terms are used interchangeably. A linear progression in the more limited sense is a melodic diminution where each tone has consonant support in the bass. Diminutions tend to occur at the foreground of an analysis, while linear progressions are more likely to be seen at some stage of the middle ground. We saw earlier how the passing tone that fills in a third is the smallest possible melodic diminution. For the same reason, the smallest possible linear progression is called a passing chord, wherein we give consonant bass support to a passing tone. This is the same second species dissonant passing tone that we saw earlier. To transform this dissonant diminution into a linear progression, we have to give it consonant support in the bass. I'm going to add a bass note that gives the passing tone A consonant support and also add in inner voices so that we can see a full chord progression. Here we have a simple chord progression in the key of G major. Notice that the formerly dissonant note A in the soprano voice now forms a perfect octave against the A in the bass, and that the outer voices form correct first species relationships in contrary motion. Let's now render this keyboard-style progression into analytic notation. The soprano line should look pretty familiar. It's the same configuration for a melodic diminution that we saw earlier. The bass voice also shows the same relationship. Two stemmed notes, G and B, are connected by a slur that represents a consonant skip, and the passing tone A is contained underneath that slur and remains unstemmed. The inner voices in this case are not doing anything particularly contrapuntally interesting, so they're shown in tiny unstemmed note heads that are not connected to anything. My advisor used to call these notes raisinets. You can think of them as tones of the imaginary continuo, and we show them in the inner voices when we want to illustrate the chord or harmony, but unconnected tones like these would not be acceptable in the outer voices. The analytical reduction also allows us to compare the linear functions of these chords. Notice that the tonic chords on the downbeats of this example feature structural tones in the outer voices, while the 5-6-4 chord in the middle is formed out of unstemmed notes of lesser structural weight. We can say that this middle chord is a passing chord. It is generated by the contrapuntal passing motion between structural chords. One of the strengths of Schenkerian analysis is that it allows us to distinguish in very precise ways between these kinds of voice-leading chords and structural harmonies. I should mention that this notion of linear function is completely separate from harmonic function. In this example, a dominant chord is generated by the connection between two tonic function chords, but you could also have a situation such as this one, where a root position tonic chord connects two chords that have dominant function. The moral is that not all one chords behave the same way, and the same can be said for 5 chords and 4 chords, etc. We have to consider linear context if we want to really understand how a certain chord is behaving. Before moving on, I should mention that this example of a passing chord is a special situation known as a voice exchange. Schenker often used diagonal lines to show long-range connections such as these. One line connects the soprano B of measure 1 to the bass B of measure 2, and the other line connects the bass G of measure 1 to the soprano G of measure 2. It's as if the outer voices have traded notes. Diagonal lines crossing each other like an X often indicate this kind of voice exchange. There is another very important piece of analytic notation that we should cover before we leave the topic of linear progressions. Let's listen to this famous melody by Bach. As you listen, see if you can identify the two contrapuntal voices that make up this compound melody. Now let's see the melody represented in analytic notation on the upper staff. In analytic notation, beams are used to show a group of tones that participate in the same action. The structural tones of the upper voice in this example, G, F, and E flat, are beamed together to show the motion of the upper voice, and the lower voice tones B flat, A flat, and G are likewise grouped together using a beam. Notice that the structural tones of these two beamed patterns move in parallel sixths, not unlike the example of a compound melody from the end of the previous video. These beamed structures are both linear progressions that could have just as easily been represented with stems and slurs. However, it is nice to have two different ways to show melodic connections, since if we tried to show all of the relationships in this compound melody using only stems and slurs, there would be many overlapping slurs, and the graph would look quite cluttered. Conventionally, beams are used to show structural connections closer to the middle ground and background, while slurs are used for more surface-level connections. Diminutions and linear progressions can be used to generate motion between the tones of a single voice, as we've seen, and they may also be used to connect the voices of a polyphonic texture. Here is another famous tune by Bach from his notebook for his second wife, Anna Magdalena. Let's apply analytic notation to the first half of this melody, and only to the notes of the right hand. Here we see another compound melody with stems going up and stems going down. Motion between the voices occurs in the first measure. The structural G of the alto voice is connected by a slur to the D of the soprano on the downbeat of measure 2. The slur is filled in with a stepwise diminution, which forms a sort of bridge between the two voices. This is a special kind of motion called motion from an inner voice. This one happens to be fairly surface level, but in many analyses, Schenker showed how motions from an inner voice at the middle ground could organize very large spans of music. The last major topic of this video is the neighbor note, and its offshoot, the incomplete neighbor. Whereas diminutions, linear progressions, and motion between voices can be used to create motion between structural tones, neighbor notes allow composers to create a sense of motion around structural tones. I didn't include a discussion of neighbor notes in my series on species counterpoint, since Fuchs does not allow for them in Gradus ad Parnassum. All later contrapuntal theorists, including Padre Martini and Schenker, do allow for neighbor notes, however, so I will go over how they work now. Here is a measure of third species that includes a dissonant neighbor note on beat 2. The dissonant F is approached by step and left by step in the opposite direction. This is different than a passing tone, which would have continued to a consonance in the same direction. Neighbor notes always return to the consonants from which they came. Let's show the neighbor note configuration in analytic notation. The neighbor note itself is often labeled with a capital N, although you will also sometimes see NN or in German NBN as abbreviations. Neighbor notes are given stems and eighth note flags to set them apart visually from other kinds of elaborations. The neighbor note is contained underneath a dashed slur to emphasize that the structural tone E on beat 1 is the same E that occurs on beat 3, and to show that the consonant sixth formed between this E and the cantus firmus is the controlling relationship for all three beats underneath the dashed slur. This is what I meant when I said earlier that neighbor notes create a sense of motion around a structural tone. It is only a sense of motion because we didn't end up progressing anywhere, but instead returned to where we came from. Passing tones and linear progressions can be used to connect and move between different structures, whereas neighbor notes prolong and sustain the same structure. In the same way that we could create passing chords by giving consonant support to a passing tone, we can also create neighboring chords by giving consonant support to a neighbor note. Here we have a keyboard-style chord progression that might be explained by a harmonic theorist as a tonic chord followed by a subdominant chord, which then resolves by plagal motion back to the tonic. An alternate explanation is revealed when we convert this passage into analytic notation. Here we can see the structural relationship of a fifth between the outer voices C and G is prolonged by an intervening neighbor note, A, on the upbeat, before the upper voice returns to the G on the next downbeat. The linear function of the four chord is to give consonant support to that neighbor note. Finally, many different kinds of melodic ornaments, especially unprepared dissonances, such as appoggiaturas and accacciaturas, can be explained in terms of what Schenker called an incomplete neighbor note. Here again is the typical configuration of a neighbor note. The third between C and E is prolonged by a dissonant neighbor note F. If, for whatever compositional reason, the composer were to omit the first structural note E, we would have something that looks like this. The dissonant F is now labeled with an abbreviation IN for incomplete neighbor, and it is connected to the structural tone E by a solid slur. I decided to include the missing initial E as an implied tone written in parenthesis, but in most analytic reductions, the missing part of an incomplete neighbor is not shown at all. We can call this pattern a front-relating incomplete neighbor, since the dissonant tone happens before the structural tone that it depends upon. The return to the structural tone may also be omitted. In this case, we would say that the incomplete neighbor back-relates to the structural tone. If you've been paying attention throughout this video, you may be asking yourself at this point, if there are passing tones and passing chords, and neighbor notes and neighboring chords, do incomplete neighbors also allow for incomplete neighboring chords? The answer is yes, although they are significantly rarer than the other kinds of voice-leading chords. Here's the beginning of the theme from the slow movement of Beethoven's Ninth Symphony. And here is the passage rendered in analytic notation. On beat 2 of the first measure, we can see an incomplete neighbor A natural that front relates to the B flat on the next downbeat. In the bass voice, an incomplete neighbor E flat similarly front relates to the bass note D on the next downbeat. Beethoven harmonizes these incomplete neighbors with a 5-4-2 chord, and the best explanation for that chord is as an incomplete neighboring function that resolves to the 1-6 that follows. We covered a lot of material in this video, and in fact we could have spent an entire video on each one of these concepts. The main theme underlying all of the topics was the concept of using stepwise motion to fill in the melodic spaces that are defined by the horizontalized intervals we covered in the previous video. In our next lesson, we will cover harmonic transformation and the ways in which Schenker's theory explains chromaticism in Western music.